Hello and welcome to Teaching Math. Today we're going to discuss everything we need to know about Pythagorean theorem. But before we get there, we really need to know what is area of a square. So we're going to be dealing with few shapes. You will be wondering, what do you see in front of you? What is this odd shapes? From this particular combination of shapes, you can clearly see there are squares and triangles. So this is the core of Pythagorean theorem. So let's get started and see what does it mean when we're talking about Pythagorean theorem. So in theory, we would have two sides of the triangle. And if we know the two sides of the triangle, then we will be able to find the third side length. So that's the key. But let's understand, why is it like that? Why knowing two sides will help us to find the third side. All right, so let's start to find the area for each square. So that's our first step. So for the green one, we can see there's 3 units here. So the side length will be 3. For our yellow one, it's 4. And for our red one, it's going to be 5. Well, let's define what is the equation to find the area of each square. So we know find the area of rectangle or a square is to multiply length with width. So, okay, we know that for sure, but square is a bit different because all sides are the same size. So the length and width are the same size. So another way that we can write for the square is squaring it or multiplying it by itself. So let's go ahead and try the first one, and then you'll see what I mean. So the area of the green side will be 3 times 3, or another way we can write this is 3 squared. And that will equal 9. Okay, so let's go ahead and write that 9 square units in here. Okay, we found the surface area for that square, and let's go ahead and find the surface area for yellow square. So area will be, again, we're doing length times width. Since it's the same one, we can write 4 times 4, multiplying by itself, or we can write 4 squared. And that will equal 16. Okay, and we have one more left, which is the red area. And that will be 5 times 5, or we can rewrite it as 5 squared, which will equal 25. This one is 16 square units, and the red one is 25 square units. Okay, so then let's go ahead and do one thing. What I'm going to do is add the yellow, 2 small sides, the yellow and green together. So then green side, the area is 9, and then we're just going to add plus, and then the yellow side 16. And what does that equal? It equals 25. So what do you notice what happened here? We basically have this right angle triangle. And to find the third side, we can square, right? Find the area, like create this imaginary square that attached to each side and find the third side. And in theory, when we do that to 2 small sides, we add them together, it will be equaling the area of the side that is longer, so that imaginary square that we've created. But we can't really stop there, because in theory we wanted to know the side length rather than the area, right? But that's the thing. The first step, we need to find the area. We need to create this imaginary triangles and then find the side length. But you know that anything squared could be square rooted. So we can find the side length of this third one by square rooting 25. Obviously, that will be 5. So then the third side will be 5. How do I know which sides to add and which sides not to add? And so here where things get very interesting. I'm going to draw another triangle so you can clearly see what I mean. All right, let's talk about our triangle, because this is very important. It has different sides and which one goes where. So we name those sides like this: A, B, and C. Okay, so this is because every single side is different size and it has different function. So A and B, look at what they're attached to. They are attached to this right angle in here. And you know when they're attached to the right angle, then you have the A and B. Now, you may think like, how do I know if it's A or B? It really doesn't matter if you're talking about A and B. We can use that interchangeably. So let's go ahead and say A, right? We call this a leg of the triangle. And B also is the leg of the triangle. And how do we know it's the leg of the triangle? Because, well, it's connected to the right angle. And then now you may ask, like, what if the right angle sign is not there? It's always there. When we don't have the right angle sign on your triangle, that means it is not a right angle. So you cannot apply this theory to the Pythagorean theory to this triangle. So you will always have this right angle to let you know those are the legs. And as you remember, we added the legs to equal to the side of which is now a C. So what do we call the C? We call the C the hypotenuse. So C is the hypotenuse. Okay, so it's a hard name to remember, but if you can remember, that's the longest side and it's across, right? It's across from the right angle. You will know that is the hypotenuse. And so let's go ahead and write our equation for our Pythagorean theorem. So what we did was we squared the one side, right? And then we added and squared the other side. And we're talking about the legs, the two short sides. And then it equaled the third side squared. As you remember, we squared the 3 and then squared the 4, and it equaled 5 squared. So let's go ahead and write that down. As you remember, we squared the 3, which was 9, squared the 4, which was 16, 9 plus 16, and the same thing as 5 times 5 equals 25. And that is the gist of your Pythagorean theorem. Okay, erase the B, and let's have an example here. So I'm going to say that this side, and this has nothing to do with the units or how big this is. Okay, so I'm going to say that this side is 6. This side is, obviously has to be bigger than 6. So let's go ahead and say 8 units, and we don't know what this side is. Now we have to evaluate what we know. We know the 2 legs, and that means we can add those 2 together. So our equation goes, again, a squared plus b squared equals c squared. So let's go ahead and start doing that. When you're just starting this, go ahead and write a and b for yourself so you can clearly see what you're dealing with. So that's my b, and this is c right there. Okay, now that I identified everything, I can start my work. So a squared, a is 6, or you can go ahead and write it like this. A equals 6, b equals 8, and then c, I don't know. Let's go ahead and do that. A squared, which will be our 6 squared, plus b squared, which will be our 8 squared, should equal c squared. Now we don't know what's c, but our equation says it equals c squared. All right, so 6 squared, it will equal 36, plus 8 squared will be 64. And so all of this should equal c squared. Okay, what is 36 plus 64? That will be 100 equals c squared. Now remember, we need to get rid of that square. We found the area, but not the side length. But we know how to find the side length when something is squared, right? A number is squared. We can find the side length by square rooting the number. So square root, both of them will be square rooted. So square root of 100 is 10. So then c squared under the square root, radical sign will be c. All right, so our length on the longest side will be 10. Okay, so let's go back in here and write that c equals 10. We know that now. As you can see, we have one small side, one medium, and one large one. Let's do another, but I want to change a few things in here. Okay, let's go ahead and do another example. What if I knew this side, which is 15, which will be our red side, and then our yellow side is 12, and our green side is, well, we don't know. Really go back and think about like which one is what, which one is A, B, and C. If you remember, I told you that A and B are the legs. They are connected to the right angle. So let's go ahead and find that right angle. Here's my right angle, and this should be my A, and that should be my B. And so let's go ahead and write that down. So this is A equals, and this one is our B. And obviously the red side will be my C. How do I know? Well, because it's across from the right angle. That is the longest side. So interesting here, we know what is the hypotenuse, which is the longer side, C, but we don't know what is A, one of the legs. So what do we do now? Well, don't panic. We're just going to write our equation just to remind ourselves what is the Pythagorean theorem and what did we do before. We basically squared two legs and added them together to equal the last leg, and then what we did at the end, we square rooted that number to find the side length. Remember, when we're squaring something, we're finding the area of a square that we're creating on the side of each triangle, much like this one with before. So it's kind of like this. Imagine this is what we're creating. Okay, so let's go ahead and write what we know. So we know that A, question mark, we know that B is 12, and we know that C is 15. Let's plug in all of these numbers inside the equation. It's that simple. So A squared, because we don't know, but we know what's B, 12 squared, equals, we know what C is 15 squared. What do we do now? Well, we square everything. We don't know what's A squared, so we're going to leave it as it is. So 12 times 12 is 144, equals 15 times 15 is 225. Now here we're going to treat it as if we're solving an equation. Here's our variable, A squared. How do we do that? We have to isolate A squared. That means we're going to do the opposite, right? Rewind the tape. So for now, we're going to, if 144 was added to 8 squared, then we're going to subtract 144 from both sides. Okay, so this will be 1. 12 minus 4 is 8. And then 1 minus 1 is 0. So let's go ahead and bring the A squared in here. Now, remember, we created this square on that side. Now we have to find the side length. And to find the side length of a square, we should be able to square root the number. So square root of A squared and square root of 81. Square root of A squared is A, and square root of 81 is, you guessed it, 9. So the A side is 9. So let's go ahead and write that down, that A, let's erase this, A equals 9. Now let's erase on both sides. Let's recap what we learned from all of this. Now, one thing that you have to remember, the Pythagorean theorem says that if you know the length of two sides of the triangle, you will be able to find the length of the third side of a right triangle. Remember, we're talking about only the right triangle. We also learned that right triangle has legs. Those are the two shorter sides, and it has a hypotenuse. And the way we identify the legs is just looking at where the right angle sign is, because both legs are connected to the right angle. Now, what we did here, in order for us to find the third side, what we did here is we created this imaginary squares by squaring the side length of the triangle. And so that's what we did. If we knew the side length, like this one in here, 3, we squared that 3 and then squared the other side length, which was 4, and found that when we add those two squares that we've created together, we will have the third side square, which will be connected to basically the third side of the triangle. And knowing this area of this side of the triangle, we're able to find the side length by square rooting it. So this is what it is, but the most important thing for you to just kind of remember is where are our legs and where's our hypotenuse and what are we looking for. As you remember from our previous example, not always you'll get the legs, so you need to treat a squared plus b squared and c squared as an equation, and you need to solve it as an equation as well. So one of the most important things that my students always confuse is which ones are the legs and which ones are the hypotenuse. That's the only thing. If you get that one down, you should be able to plug in those numbers in your equation and find the answers. All right, so let's recap. The two short sides, they're attached to the right angle, are the legs, and then the long side is the hypotenuse, as you remember. And our Pythagorean theorem is, the formula is something that you should try and remember: a squared plus b squared equals c squared. And no matter which side, two sides you have, remember you have to have two sides, you will be able to find the other side, the third side, by using a squared plus b squared equals c squared. Now there is one other shortcut that I usually teach my students. You know, it's the same thing, but it's kind of a shortcut for you. So if I have the hypotenuse and I have one of the legs, for instance, here, I would have just quite quickly done the second step and subtracted the leg from the hypotenuse, like this: 15 squared minus 12 squared. And that will equal a squared. And if it was b squared, then I would have said b squared. And as you can see, this will be like much faster if this is what you want to do, and this is your kind of shortcut in here. And that will be 81 equals a squared, and then square root each number, which will be 9. All right, so that's another way you can do that if you know you have the hypotenuse. And as you can see, it's very easy to distinguish, do we have which sides do we have? Do we have the hypotenuse and a leg, or do we have both legs? Remember, when it's both legs, you add, and when you have the hypotenuse or any of the legs, you subtract. But that is your shortcut. Okay, so if you learned something new, please subscribe to Teaching Math. And remember, learning math takes patience, practice, and perseverance. Remember to ask some questions in the bottom. If you have any questions, I'll be more than happy to answer. If there is a part that you did not understand or I didn't cover a specific problem, I will be able to answer those questions. Take care for now.